SpaceX achieved a groundbreaking engineering feat on Sunday with the fifth test flight of the massive Starship rocket, followed by the booster's return to the launch pad in Texas using mechanical arms just 7 minutes later. However, as we observed, some of the Raptor engines on Super Heavy B-12 encountered issues while landing in position for the catch. How did Musk explain this? Let's break it down in today's episode of the Space Droid. Was that fire caused by Super Heavy Raptor engines? If you closely followed SpaceX's Starship Flight 5, especially the remarkable landing of the Super Heavy, you might have noticed the fire at the bottom of the booster at around T+6 minutes and 32 seconds, which intensified at 6 minutes and 39 seconds. The flames were clearly visible in the engine bay, raising concerns that there might be an issue with Starship's engines. However, that was not the case. During the entire 7-minute flight from liftoff, all 33 Raptor engines operated flawlessly. None of the engines shut down unexpectedly as seen in previous launches, and none failed to restart. In fact, they executed both shutdown and restart procedures smoothly and efficiently. The moment when Booster 12 used 3 Raptor 2 engines to precisely redirect itself toward the catching tower was breathtaking. The process was 100% smooth and precise, not just 1 or 2. 3 engines worked together in perfect synchronization, delivering rhythmic controlled movement. The accuracy of the thrust vectoring and gimbal systems was extraordinary, allowing the booster to perform complex maneuvers with grace and fluidity. The motion was so controlled that it almost felt like watching CGI-rendered animation, a testament to the real-world precision required for such feats. This demonstrates the system's impressive ability to finely adjust thrust for delicate, high-stakes maneuvers. Of course, we can't overlook the role of Mechazilla, SpaceX's catching tower. The tower and its chopstick arms were thoroughly tested for stability, even at the top where they bore significant pressure. Post-launch images revealed that Booster 12 still contained nearly 500 tons of fuel. To put that into perspective, the chopstick arms had to support the equivalent of 80 African elephants, 16 train cars, or 3 fully grown blue whales, each weighing around 200 tons. Yet the catch appeared incredibly gentle, with hardly any visible vibration. This smoothness was due to the new design of the chopstick arms, which SpaceX equipped with bumper pads featuring high elasticity. These pads helped slow down Super Heavy and absorb its inertia, making the catch look effortless. A slow-motion close-up even shows how well these 16 bumper pads performed during this crucial moment. But wait, did we overlook something? If everything worked smoothly and was coordinated well, then why did the fire appear in the lower engine bay? The likely cause began at 6 minutes and 9 seconds post-launch when Booster 12 was descending without thrust, relying solely on guidance from the grid fins. Given Super Heavy's considerable weight, its descent speed is significantly greater than that of the Falcon 9 booster. A close examination of a photo taken at the moment reveals that the engines were extremely hot due to air friction, glowing red, even though no engines were firing. This phenomenon is attributed to atmospheric heating inside the engine bay, which caused the heat shields to reach such high temperatures. As the temperature rises, gas leaks can occur, which likely explains the small fire seen in the engine bay. Fortunately, the fire was relatively minor, indicating that the leak was not severe, and further demonstrating that the Raptor 2 engines were functioning properly. Elon Musk, SpaceX's chief engineer, tweeted an update regarding the Raptor engines. A few outer engine nozzles were warped from heating and some other minor issues, but these are easily addressed. This statement provides reassurance about the condition of Booster 12's Raptor 2 engines, indicating that these minor issues will not significantly impact the engine's performance and can be resolved without major complications. The term easily resolved applies to both the current Raptor 2 engines on Starship version 1 and the next-generation Raptor 3 engines of Starship version 2, which was recently announced. Observing the warping of Raptor 2 might prompt thoughts of the sleek black appearance of Raptor 3. Could this be a hint from SpaceX? Is the black color of Raptor 3 simply a coat of paint, or is it made from a different heat-resistant material? If you have insights on this, feel free to share them in the comments down below. One thing is certain: SpaceX will soon provide more information about Raptor 3 as they rapidly advance toward the next generation of a larger Starship. With this level of potential, we can conclude that Raptor 2 is still primarily an experimental engine, while Raptor 3 is SpaceX's true ace up their sleeve. Raptor 3 represents a significant improvement, addressing all the weaknesses of its predecessor. In a recent post, Musk explained that the small plumbing and wiring associated with the engine had to be either removed or integrated into the engine's primary structure, as Raptor 3 will not have a heat shield. Additionally, all parts must be actively cooled, so they added regenerative cooling in areas where there was previously no fluid or gas flow. Musk noted that this regenerative cooling method circulates cryogenic methane outside the main combustion chamber to keep it cool. The warm liquid methane then flows into the pre-burner, continuing the cycle. Consequently, Raptor 3 no longer requires an additional heat shield, unlike earlier engine versions. But that's not all. Raptor 3 also eliminates many small pipes and wires by integrating them into its main structure. Moreover, it merges various components into single complex pieces using 3D metal printing on the engine walls. As a result of removing, integrating, or simplifying these components, Raptor 3 weighs half as much as Raptor 1. Including the mass of the engine and associated hardware, the total weight of Raptor 1 is 8,000 pounds, while Raptor 2 weighs 6,430 lb. In contrast, Raptor 3 reduces the total weight to 3,790 pounds, with 3,362 pounds attributed to the engine and 428 pounds to the induced mass. Given that Super Heavy, the first stage of Starship, is equipped with 33 Raptor engines, and with SpaceX planning to add 2 more, the weight savings between the current and next-generation engines amounts to 40 tons. This meticulous simplification process not only reduces the engine's weight, but also enhances its rapid reusability. Furthermore, it boosts SpaceX's capacity to mass-produce Raptor engines. The no part is the best part manufacturing approach minimizes assembly needs, improves structural integrity, and reduces material waste, leading to more efficient and sustainable production processes. These advancements will be crucial as Elon Musk aims to reduce the turnaround time between Starship flights, potentially to 1 Starship per week or even 1 per day. The Raptor engine is truly the ultimate all-purpose engine. According to SpaceX, the Raptor 3 engine can generate a downward thrust of 280 tons. While it may not be the most powerful rocket engine ever, it stands out among all active rockets and is far from lacking in capability. Reusability is a major focus in the design of the Raptor. SpaceX aims to reuse each engine 1,000 times, and since most other rocket engines have limited or no reusability, the cost per flight of the Raptor will be relatively low. This will make space travel more affordable and accessible in the future. SpaceX has set ambitious cost targets for the Raptor engine, aiming for a production cost of less than $1,000 per ton of thrust, which translates to approximately $250,000 per engine. Achieving this goal would enable cost-effective production and facilitate the scalability of space exploration efforts. In 2022, SpaceX announced its capability to produce 1 Raptor engine per day at its McGregor facility in Texas, demonstrating significant progress toward meeting these production targets. A key feature that distinguishes the Raptor engine is its use of liquid methane and liquid oxygen as fuel sources, a combination known as methalox. This choice of fuel is strategically important for space exploration, particularly for missions to Mars, as both methane and oxygen can potentially be generated from Martian resources through in situ resource utilization, ISRU for short. ISRU is vital for establishing a sustainable human presence on Mars by enabling the production of propellant using locally sourced materials, thereby reducing reliance on Earth-based supplies. Moreover, the use of methane as a fuel offers environmental benefits, burning cleaner than traditional rocket fuels like RP-1 kerosene, resulting in fewer pollutants. The Raptor engine's exceptional power is instrumental in facilitating human travel to Mars, enabling spacecraft to achieve unprecedented speeds and efficiency, thus advancing the feasibility of interplanetary exploration and colonization. The development of the Raptor engine underscores SpaceX's commitment to advancing reusable rocket engine technology, focusing on maximizing reliability in even the most challenging environments. Through rigorous testing and continuous refinement, SpaceX aims to ensure that the Raptor engine becomes a cornerstone of reliable propulsion for future space missions. Beyond its technical prowess, the Raptor engine plays a pivotal role in SpaceX's broader vision of revolutionizing space travel. By driving down costs and increasing accessibility to space, SpaceX seeks to pave the way for ambitious endeavors, such as establishing a long-term lunar base and creating the first self-sustaining colony on Mars. This vision aligns with Musk's ambitious timeline, which includes sending an unmanned Starship to Mars, following NASA's Artemis missions to the Moon, potentially by the late 2020s. Once the infrastructure for refueling on Mars is in place, reusable Starships would be able to make regular trips between Earth and Mars, opening new possibilities for space exploration and settlement. To stay informed on the latest developments with SpaceX and Starship, make sure to hit the subscribe button so you won't miss a single update. Thanks for tuning in, and I'll see you in the next one.